This week we're covering circles. Okay, the first thing you need to know about circles is you have a central angle. It comes from the vertex being in the center. And what you need to know is that the angle equals the arc in a central angle. An inscribed angle is an angle whose vertex is on the circle. So if you have an inscribed angle, if you're given the angle to get the arc, you just multiply the angle by 2. And if you're given the arc, you just divide the arc by 2 to get the angle. You also have inscribed polygons, that's a polygon whose vertices are on the circle. In an inscribed quadrilateral, your opposite angles add to 180. If you look at this diagram here, I noticed that angle BED is 25 degrees, and it's an inscribed angle, so arc BD would be 50 degrees. To find angle 2, which is angle BCD, I notice it intersects the same arc of 50, so it has to be exactly the same as angle 1, which is 25 degrees. Now, you've also got angles that aren't at the center or on the circle. You've got some angles that are inside the circle. When you have that, to find that angle measure, you take the two arcs that angle creates, add them together, and divide by 2. For instance, if they gave me that the two arcs were 22 and 34, to find the angle, I just add 22 and 34 and divide by 2 and come up with 28 degrees for the angle. Now, they do get a little more complicated than that. Sometimes they'll give you the angle and not one of the arcs. Same process, it's just here you'll have to use algebra to solve for that missing arc measure. Now, what if you have an angle that is formed outside of the circle but goes through your circle? In that instance, you don't add the arcs that it intersects, you subtract them, and you subtract the bigger arc, which is furthest away from the angle, from the smallest arc, and you divide by 2. Again, very simple, big arc minus small arc divided by 2. Here again is another example of big arc minus small arc divided by 2. Now, sometimes we're not going to talk angles, we'll talk segments inside of circles. If you have two chords that intersect inside the circle, the product of the segments of one chord is equal to the product of the segments of the other chord. For instance, on this picture here, 2 times x would equal 3 times 4, which you then would do your algebra and come up with x is 6. Another scenario for your segments is two secants, and now that intersect outside the circle. In this instance, it's the outside segment of the first secant times the whole secant equals the outside segment of the second secant times the whole secant. For instance, in this picture here, I do the outside, which is 7, times the whole thing, which is 7 plus x, and set it equal to 6, the outside of the other secant, times the whole secant, which is 6 plus 8. And then by process of the algebra, we get down to x equals 5. Now, they do get a little more complicated when you get to the two secants. Sometimes they'll put x on the outside, and that'll cause you to have to go into quadratic formula or factoring. Just remember, you cannot have a negative length, so a negative would not be a feasible answer. The last scenario is tangents and a secant. The tangent is simply squared and set equal to the outside of the secant times the whole secant. Here's a good example of one. We'd square the tangent, so x squared would equal 4 times 13. You get square root of 52. The next things are just some theorems you should know. If a diameter intersects another chord of the circle, it bisects that chord and the arc it creates. If two chords in a circle are congruent, then the arcs they create are congruent. If two chords are the same distance from the center of the circle, then the two chords are congruent and so are the arcs. Here's an example where they show you they're the same distance, so you just set them equal and solve for x. If you have two tangents that intersect outside the circle, the two segments that are formed are congruent. And finally, a tangent and the radius of a circle are always perpendicular. So for instance, in this picture, if I want you to find the radius of this circle given everything, you have to use Pythagorean theorem to solve for x. Okay, I know I went a little fast. If you have any questions, please feel free to contact me or come to tutoring.